In this lesson, we're going to have a look at our PLC alarm management, starting with the alarm constants. So you've probably guessed it by now, bearing in mind we've been through a sort of alarm manager in our previous two lessons, that we are using a big array and an indexing system to manage our alarms. Personally, I much prefer this approach. It makes things really simple and easy, and you have a central alarm management system in the form of a standard block that can be used inside any asset. It can be used outside of any asset in any control system, sequence, and things like that. And it all hinges around a constant. So just like we can have constants in interfaces, we can also have constants in our PLC tags. So here I have A1 alarms, which I've opened, and you'll notice that there are no alarms in here, but you'll also notice on the details view that it's showing that there is something in here. And that's because it's hidden away on the user constants tab in the top right here. So clicking on that will reveal all of the constants, and we have A1 underscore alarms dot A1, which is assigned a value of 1 data type integer, and then a comment saying what the functionality of that alarm is. And this is just repeated for the entire size of the array. So if I come down here, you can see that it goes all the way to 255. I have an extra one in there, 256, which shouldn't be there, but so it comes down to 255 because the size of our UDT for alarms is 0 to 255. So all the ones that don't have a comment against them are spare, and all of the ones that do have a comment against them are used. And the nice way, or the nice thing about doing it this way, is that you can allocate 255 alarms to a group. You can make it more if you want. In other projects, I've had 2048 and things like that. I try to keep them as nice numbers or nice programming numbers, just for size references. But you can allocate stuff and know that you can create new alarms, and all you're doing is dropping a function, because we should be making our alarm manager as a function. It doesn't have to be, but if you make it as a function block, you're going to have to reinitialize parts of your code in order to service a new alarm. Having it as a function might just make that a bit easier, but it depends how you want to manage your actual alarm, which we'll come on to later on in this section. But once you've got all of your constants created and they've all got an individual value, it's important to make sure they all have an individual value. It's got to be unique and it's got to be within the bounds of the array. Otherwise, you're going to give yourself issues later with either indexing an alarm more than once or indexing an alarm outside of the array. Both of those will give you different problems. If you do it outside the array, your PLC might stop. If you do the same one twice, you might find that you don't raise an alarm when you need to, or you can't reset an alarm when you need to, because somewhere else is interfering with the process. So once you've got these created, we'll have a look at where I'm sort of assigning these. So if I was to cross-reference this one here, A1 is used in the input mapping layer. So our input mapping layer is not only for putting in I/O, it's also for mapping in any other inputs, such as the alarm index. And naturally, as you develop your own sort of flavor of this, you might have even more that's done through this input mapping layer, or you may choose that you want to put the alarms on the front of the interface for each individual asset, so everything's together. It's completely up to you, but the point is that we are passing this information to our asset and to the asset's data. So if I have a look on the input mapping layer where this is used, it's used here. So map IL1, filter level. In the mapping, we have the alarm for out of range is A1. And hovering over it, or in ladder, you'll have the comment above. By putting the comment on, you have a nice easy reference then of where it's used. And if we know that this is going to end up in the asset data. So if I have a look at the asset data here, and I go to typed, alarms, indexes, out of range here, if I just go online and have a look, that should have a value of 1, which it does. And we can see 1, 2, 3, 4, 5. And if we look at our alarms here, we have 1, 2, 3, 4, 5, and they're assigned low, 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 high, high, high. And these ones are high, 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 low, low, low. So it's like different order, but the correct constant is being applied. And now that it's in the asset data, we can use it inside our management block as much as we need to. Now, the reason that they are declared as constants and not as a different type of constant, not on the actual interface, is for one reason only. If I go to the input mapping, and I could, by rights, remove that and just type 1. And I would get exactly the same results, because all we're interested in is the index value for that alarm. There's nothing wrong with that at all. That will work. It won't change anything. But what it will change is if you are looking up an alarm later to see the status of that alarm. Now, I don't recommend that this is done, because you should really be looking at the asset data, but there are certain circumstances where you might want to access the alarm data directly and just see if a particular index of an alarm is on. So if we switch to ladder, because it would make this a little bit easier to look at. So main, I'll create a rung in main and just show you what I'm talking about. But if I was to create a new rung here and just say I wanted to pick out that out of range alarm, if I went to my alarm data A1 alarm and put 1 in there, that's also fine. Absolutely fine. That will work. We are checking, is that alarm active? But this approach here doesn't use the constant. So if I was to go to A1 alarms here and do a cross-reference now, we can see that it's not used anywhere, because we've removed it from the input mapping layer and we're also not using it in the code. So it makes it very difficult to understand where this alarm is being used. Because you know that it is being used on the asset manager, because it's going to be indexed. You're raising the alarm. If you were doing testing, you're seeing the alarm, but you can't follow it through anywhere. And just to demonstrate as well, you can't cross-reference constants that aren't user constants. So if I wanted to highlight that and go to cross-reference, you can't, because it's a constant. It's defined locally on the fly in the logic. It's not cross-referenceable, and it shouldn't be really, because if you were to cross-reference something just like a 1, you'd get loads of hits in a normal program, because people are assigning those to the front of interfaces and things like that all the time. And there isn't anything wrong with that, but in the case of the alarm, we want to make it easy on ourselves to understand where this alarm is being used. So setting that to A1, and then in our example on main here, if I put another one down and I did alarm data A1 alarm and then A1, that's absolutely fine. But this time, when I do a cross-reference of A1 here, we get that it's used twice. So it's used in our input mapping layer because we put it there, and it's also used as the index of this array on this instruction here. So it's nice and easy to look up where we are using our alarms. There are some other small benefits of using alarm constants. One of them being it's very easy to map this all in Excel. So using something like Excel, you have your list of your alarms. If you wanted to create a B group, for example, it's just a case of find and replace in tier portal. However, what you will find is when you are in the alarm constants, you can't use replace all for some reason. I'm not quite sure why Siemens have done that. It's really annoying, but you can go into Excel, create this table in Excel, and then just paste it straight in here, and it works fine. So it's a lot easier to create additional alarm groups and things like that when they're all bound this way and centered around constants. And that's it for that, really. So yeah, every single alarm should be tied to a constant, and the constants are used to index the array that we're using to pass information to SCADA or a HMI and to manage the alarm.